Hello students, I got a request from one of the students to help to solve this problem. It's very good question, and before solving it we're trying to understand a couple of theories so that it will be easy to solve the problem. The first of all, we have here two capacitors, C1, C2, and they're charged separately with V1 and V2, okay? So initially basically we have to find how much charges were stored in each capacitors. So the general formula will be the C is equal Q over delta V. Okay, so that means let's find first of all the charge one will be C1 times V1. Okay, the C1 was given as 8 microfarad multiplied V1 was 14.2 volts. So if you do calculation, then you should find that it's equal to the 113.6 micro coulomb. Okay, so that we can do the same thing. So this is all initial, okay, initial things, which is C2 V2. So C2 is 16.1 microfarad multiply V2 is 5 volts. Okay, so after calculation we should get that is equal to 80.5 micro coulomb. Okay, so as you can see here, we have different charges because of the potential difference. Okay, now the first of all, C is constant. Okay, each capacitor has constant capacitance. That means depending, if you increase the voltage, then you will increase the charge in the capacitor. Okay, if you decrease the voltage, then you will decrease the charge in the capacitor. Okay, capacitor is always constant. The only thing is changing here V and the Q. Okay, that's clear. Now this is all initial part. Okay, now when we connect them, positive to the positive, negative to the negative, then we have to find what is the final electric potential and what is the charges and how much charge was flowed from one capacitor to another one when they connected together. Now the second thing that we have to keep in mind is that conservation of the charge. Okay, that means before connecting, Q total initial is equal Q total final after connecting them. Okay, that means you can say that it's a Q1 plus Q2 is equal Q1 plus Q2. Okay, we know that when capacitors are connected in parallel, V across each capacitor will be the same. So V final is equal to the V1 is equal to the V2. Okay, so we can solve it now. So we can now say that Q1 is equal, we know that it's C1 V1 plus C2 V2 and equal to the Q1 will be C1 V final. Okay, because when they connected in parallel, after connecting them I call it V final plus C2 V final. Okay, so that means V final will be equal to this ones are the Q1 and the Q2, so I will just keep it as a Q1 plus Q2 divided by the C1 plus C2. Okay, so let's plug the numbers. So what we got here, 113.6 microcoulomb plus 80.5 microcoulomb divided by C1 was 8 microfarad plus 16.1 microfarad. Okay, so let's do calculation. So once you do the calculation, you can see that it's equal to the 8.05 volts. Okay, this is the final voltage. Okay, now we know that after connecting them, the potential difference across each capacitors. So after connecting them, we can say that I will call it V final. Okay. And here is also, okay, sorry. Just let me clean up this one. It means V final, okay? So that means what will happen? Now we know that we now got our final voltage was 8.05. Now, after connecting them together in parallel, we got same potential voltage, potential difference between each capacitor. That means now the charge reallocation on C1 and C2 will be different. Why? Because now that was a general term. So before we got a certain voltage, let's say V1, and therefore we got Q1, correct? But now this is initial one. But now what we got? Now we got V final. That means Q1 and Q2 has to be different, correct? Because we got different electric potential. So how can we find now Q1 and Q2? So let's find now, after connecting them in parallel, Q1 is equal C1 V final, which is 8 microfarad multiplied 8.05 volts will give you 64.4 microcoulomb. Then Q2 is equal C2 V final, which is 16.1 microfarad multiplied to the 8.05 volts, which will give you 129.6 microcoulomb. Okay, now this is the final charges when they connected. Initial charges, it was so you can take any of this, okay, Q1 and Q2, but you will get the same answer. So after connecting them in parallel, how much charge moved it from one capacitor to the another capacitor? So how can we find that one? That one will be delta Q is equal Q initial minus Q final, okay? Let's say that Q1 initial, Q1 final, or it doesn't matter, okay? They will give you same answer, Q2 initial minus Q2 final. You can just keep it in the model, okay? So that means we can say that it's equal, Q1 was 113.6, right? 113.6 microcoulomb minus Q1 final was 64.4 microcoulomb, right? So let's do subtraction. 113.6 minus 64.4 will give you 49.2 microcoulomb charge was moved from one capacitor to the another capacitor, okay? In other words, it's kind of charges were rearranging depending on the potential difference, because initially we had certain potential difference across each capacitor. Finally we had different potential difference, therefore the charges will be rearranged. But however, due to the conservation of charges, total charge initial is equal total charge to the final, okay? Now what is left here? So now we have to find what is the initial energy which was stored in the capacitor and the final energy which was stored in the capacitor. So in order to find that one, what you have to do is you have to find U initial, which means U1 initial plus U2 initial, okay? The formula of that one will be C1 V1 squared over 2 plus C2 V2 squared over 2, okay? Then you have to find after that, after connecting them, U final, energy final, again U1 final plus U2 final, which is C1 V final squared over 2 plus C2 V final squared over. So you have to calculate what is the energy initial and energy final. Then you have to find the difference between them in the model U final minus U initial. So that's it.